Section 10.0 Real Numbers Day 2. Essential question. How do you determine if a number is rational or irrational? Alright, so for this first slide it says classify each of these numbers as rational, irrational, both, or neither. Now, you haven't talked about the rational and irrational vocab words since you did real numbers the previous day. So I'm going to write a couple things down for irrational to help you categorize them. So remember, irrational numbers are cannot be written as a fraction. Oops. Again, cannot be written as a fraction. So, for example, decimals that keep going forever, and then non-perfect square roots, because a non-perfect square root would give you a decimal that keeps going forever and never repeats. Really, everything else is rational. So if you can remember those things for what is irrational, everything else is rational. Okay, so negative 4.5 is a terminating decimal. It stops, so it's rational. It doesn't keep going forever like an irrational decimal does. The square root of 64 is just 8, so that is rational. The square root of 13 is not a perfect square root. That's just like the square root of 15, so that would go under the irrational category. 9 and 16 are both perfect square roots, so that would end up giving you 3 over 4, so that's why that's rational. 3 1/2 is a fraction, which is rational. 3,000 is just a regular number, rational. Pi is irrational, because remember that's 3.1415, and it keeps going forever. 0 is rational. 0.55555, that's a repeating decimal, so that's rational. I'm running out of space here, so I'm going to put it outside there. 7.24 is a decimal that stops, so it's rational. 2714, none of those numbers repeat, and we have the ... at the end, so irrational. Now notice that I don't have any numbers in both or neither. And that's because if you're looking at just one number has to be rational or irrational. It cannot be in both, and it can't be neither. So if you're looking at one number, it's got to go in one of those top two categories. All right, put these numbers in order from greatest to least. If you're ordering numbers, the easiest thing to do is turn all the numbers into decimals. So turn all numbers into decimals. And I would write this list again on the right-hand side to make it a little easier for you. Okay, so let's go through these one by one. So 4.3 is already a decimal, so I don't need to do anything with that one. Negative 2 is an integer. I don't need to turn that one into a decimal. I would be able to order that without it. Okay, so let's do the other 3 in the middle then. So pi, well, we all know pi is 3.14. You don't have to do any more decimals than that. So now we have that as a decimal. The square root of 8. So we're going to figure out which two perfect squares fall on both sides of the square root of 8. Well, the square root of 4 is the one smaller than 8. The square root of 9 is the square root bigger than 8. So the square root of 4 is 2. The square root of 9 is 3. So that means my decimal is going to be somewhere in between 2 and 3. Now the square root of 8 is only one smaller than the square root of 9, so that means my decimal is going to be really close to 3, because 8 is only one away from 9, so the square root of 8 is really close to 3. So I'm going to go 2.9. What is really close to 3 but a tiny bit smaller, 2.9. So now we have that as a decimal. And then last but not least, I have 16 over 3. So what I'm going to do for 16 over 3 is I'm going to do long division. So I'm going to take the 16, put it inside my fraction bar, and put the 3 on the outside. How many times can 3 go into 16? 5 times. 16 minus 15 is 1. Bring down the 0. How many times can 3 go into 10? 3 times. And I could keep going here. I'm not quite done. But as long as I have a 5.3, I've turned that into a decimal. It's not going to matter if it's 5.32 or 33 or 34. That's not going to change my answer when I order these. So I'm just going to stop at 5.3. So now I have 5 numbers that I can more easily order. Now keep in mind, they want us to go from greatest to least. So find your biggest decimal. My biggest decimal was the 5.3. So you're going to put the original number 16 over 3 first. Don't put the 5.3. You want the original number. Okay, so that one is done. Then we're going to go next biggest, which is the 4.3. Remember that one we didn't have to change. It was already a decimal. Then we have the 3.14, so pi. Then we have the 2.9, which is the square root of 8. And then we have the negative 2. So now I have ordered all 5 numbers from greatest to least. Be careful, your homework may say greatest to least or least to greatest, so make sure you read carefully. All right, what kind of numbers are included in this set? Rational, irrational, both, or neither? So the easiest thing to do with a set of numbers is go number by number and determine if it's rational or irrational. So pi is irrational. The square root of 4 is 2. 2 is rational. Square root of 11 is not a perfect square, so that's irrational. The square root of 7 is not a perfect square, so that's irrational. The square root of 16 is 4, which is rational. So this set of numbers includes both rational and irrational. So my answer is both. Both rational and irrational. All right, we are going to select the correct symbol to fill into the box. Less than, greater than, or equal to. So I am going to bring this over to this side as well. We're going to have to do a little work to find some of these out. Now once again, to compare numbers, I am going to turn these all into decimals. Decimals is by far the easiest way to compare numbers. So pi is the same as 3.14. The square root of 9 is 3. So if I compare 3.14 and 3, 3.14 is the number that is bigger, so I'm going to put a greater than symbol. Remember, the mouth has to eat the bigger number. 3.14 is bigger than 3, so pi is greater than the square root of 9. All right, square root of 11. Find the 2 perfect squares on both sides, so 9 and 16. Square root of 9 is 3, square root of 16 is 4. So that means that this square root of 11 is going to fall in between 3 and 4. So it's going to be 3 point something. And we don't know what it is going to be, and we don't really need to figure that out because we're comparing 3 point something and 1.75. And 3 point something is going to be bigger than 1.75 no matter what. So the square root of 11 is greater than 1.75. All right, on the third one, we need to take the square root of 5 and write the 2 perfect squares on both sides. So 4 and 9. So 2 and 3. So that means this is going to end up being 2 point something, because it's the square root of 5 is in between the integers 2 and 3. So 2 point something, again, we don't know what that something is, but it's not going to matter. 5 is bigger than 2 point something, so once again, greater than. So 3 greater than so far. And then last but not least, square root of 31. So 25 and 36 are the two perfect squares on both sides. Square root of 25 is 5. Square root of 36 is 6. So it's going to be 5 point something. It's in between 5 and 6. So 53 is bigger than 5 point something. So the mouth eats the 53. Now I probably should have made a list of perfect squares on this slide before I did it. If you have troubles doing something like this, make that list of perfect squares. So remember where we did like 1 equals the square root of 1, 2 equals the square root of 4, 3 equals the square root of 9, 4 is the square root of 16, 5 is the square root of 25, and so on. So if you feel like you need to do that on your homework in order to be able to figure those out, go for it. All right. Which of these statements is true? It is an integer, rational, irrational, or neither. So we have to figure out what our answer is going to be. So here you're going to make a little chart on the right-hand side before we actually start solving this, because it's actually going to be easier than it looks. So when you have two rational numbers, you are always going to end up with your answer being rational. If you have a rational and an irrational number, you're always going to end up with an answer of irrational. If you have two irrationals, you're always going to end up with an answer of irrational. So the only time you can end up with a rational answer is if both numbers are rational. So using that, let's go look at this first example. So 10 times the square root of 13. Well, you have to ask yourself, is 10 rational or irrational? It's rational. The square root of 13 is an irrational because it's not a perfect square root. So a rational and an irrational make an irrational. So our answer is going to be irrational. So notice how we didn't actually do any math there. We didn't figure out what the square root of 13 was and then times it by 10. All we did was identify what kind of numbers they are. And then 13 is a rational number. The square root of 60 is not a perfect square, so it's an irrational. So once again, we have a rational and an irrational, making our answer irrational. So anything involving an irrational produces an irrational number when you solve.